Hello students, welcome to Creata Classes. I am Gurmeet Singh and also welcome to complete series on chapter Circle for class 10th students. We will cover all these lectures in this series using the power of visualization and animation. Especially in this lecture, we will cover NCERT exercise questions. These questions are very important, and for other lectures, check the link in the description. So without taking any further time, let's start with this lecture. Best of luck. Example number 1. Prove that in two concentric circles, the chord of the larger circle which touches the smaller circle is bisected at the point of contact. So this is the question. The standard rule of Creata Classes: firstly we observe the question, then only we proceed with the answer. We do not directly jump with the formulas. So let's understand this question. Here let's have the circle C1. We have given the name to the circle as C1. And this circle C1 is having a chord. Let's give the name to this chord as AB. What is chord? Chord is a line segment which joins any of the 2 points on the circumference of the circle. Here we are having the chord AB. Further, this question is also talking about another circle which is concentric to the circle C1. Let's take this circle as C2. Concentric circle means both the circle will have the common center. Here the circle C1 and C2 will share the common center as point O. Further, it is also given the chord AB is touching the circle C2. Let's give the name to this contact point as P. Further, we have to prove that this point of contact, that is point P, is dividing the chord AB into two equal parts. The point P is bisecting the chord AB. It means we have to prove AP and PB are equal to each other. That is, both of this line segment we have to prove as equal. So this is the observation that we got from this question. Further, on analyzing this figure, we can say AB is chord to the circle C1. And for the time being, if we dissolve this circle C1, can we say this chord AB or this line segment AB is an tangent to the circle C2? For the time being, we have just dissolved the circle C1 so that we can clearly visualize the circle C2. So here AB is tangent to C2 because it is only touching the circle at one point, that is point P, which is the point of the contact. We know tangent only touches the circle at only one point. If it is touching the circle at 2 points, then it is a secant. So here we can say that AB is a tangent to the circle C2. So AB is common in both the circle. For the circle C1 it is an chord, and for the circle C2 it is an tangent. Further, let's join O and P, which is the radius for this circle C2, and we have done the concept, that is theorem 10.1, that is tangent and radius are 90 degree to each other or perpendicular to each other. So this angle will be 90 degree angle. Got it? We have simply used the theorem, the radius and tangent are perpendicular to each other. Further, for the time being, now let's dissolve the circle C2 and let's retain the circle C1. Here for the circle C1, here AB is the chord and OP is perpendicular to this chord AB. And in the previous classes you have done the concept, that is, if we take any of the chord and if we draw the perpendicular bisector, it will touch the center point of that circle. So we can say that OP is the perpendicular bisector of AB. So AP and PB will be equal to each other. Point P is the bisector of the line segment AB or the chord AB. So we got our answer, AP and PB are equal to each other. Got it? We have used three concepts. The first concept we have used is AB is tangent to the circle C2. The second concept we have used is that radius and tangent forms a 90 degree angle, or we can say radius and tangent are perpendicular to each other. The third concept we have done is that the perpendicular bisector of a chord passes through the center of the circle. So we got our answer, that is AP is equal to PB. Let's move to question number 2. Two tangents TP and TQ are drawn to a circle with center O from an external point T. Prove that angle PTQ is equal to twice of angle OPQ. The first rule of Creata Classes, we will observe and analyze this question. This question is talking about a circle. Let's have a circle which is having two tangents, tangent TP and tangent TQ. Here point T is the external point and we are having two tangents TP and TQ. It means point P and Q are the point of contact. Further, OP is the radius. In this question, we have to prove angle PTQ, this angle, is equal to twice of angle OPQ, this angle. Before proceeding with the question, let's understand some basic concept that will be used in this question and which you should know to solve similar type of question. Whenever we are having an external point and we are having two tangents from an external point to a circle, those two tangents will be equal to each other. The theorem 10.2 we have done. It means TP and TQ will be equal to each other. These are the two tangents to a common circle from an external point. So these two tangents will be equal to each other. This is one of the concept. Moving next, are you able to observe this triangle TPQ? So this is a triangle which is an isosceles triangle. Why? These two sides are equal to each other. An isosceles triangle is a triangle in which two sides are equal. Further, we also know a property of a triangle, that is the angles opposite to the equal sides are equal to each other. This is an isosceles triangle. It means these two sides are equal. It means the angle opposite to these two sides will also be equal. Basically, these two sides are equal, so these two angles will also be equal to each other. So this is one of the concept. One more concept that we should know, that is the theorem 10.1. The angle between the radius and tangent is 90 degree. The radius and tangent are perpendicular to each other. It means this angle will be a 90 degree angle. So based on these concepts, we will solve the question. So let's proceed with the question. Let's assume the angle PTQ as equal to theta. Let's take the triangle TPQ. Here angle T is theta, angle P and angle Q are both equal to each other. For the time being, let's take P and Q as x for easy solution. Let's apply the sum property of the triangle, that is the sum of three angles of a triangle is equal to 180 degree. Angle T is theta. Let's solve for x. We got angle x as 90 minus theta by 2. It means these two angles are x and these two angles are equal to 90 minus theta by 2. For the time being, we need only angle P. Let's remove this angle Q. Further, we know this complete angle OPT is a 90 degree angle. The angle between the radius and tangent is 90 degree perpendicular to each other. And the angle OPT is composed of two angles, the angle OPQ and angle QPT. So angle OPQ plus angle QPT is equal to 90 degree. And just now we have calculated the angle QPT as 90 degree minus theta by 2. Let's put it. We got angle OPQ is equal to theta by 2. And in the starting of the lecture, we have assumed angle PTQ as theta. Let's put it. We got our answer, that is angle PTQ is equal to twice of angle OPQ. So the concept that we have used in solving this question, which may also be applicable in the future questions. The list of the concepts are: from an external point, tangents to the circle are equal to each other. We can have two tangents from an external point and the two tangents will be equal to each other. Theorem 10.2. The second concept, the angle between the radius and a tangent is 90 degree. That is, radius and tangent are perpendicular to each other. The theorem 10.1. And the last concept, whenever you are having two tangents from an external point that are equal, join the point of contact, it will form an isosceles triangle. And the angles opposite to the equal sides are equal to each other. So based on these three concepts, we have solved this question. So we have done with the example number 2. Let's move to example number 3. Students, a information for you: download the PDF of the formula and concept list for this chapter. The link is given in the description. There you will also find the similar PDF of the concept and formula list for other chapters too, especially for the class 10 student. So check the link in the description, and now back to the lecture. PQ is a chord of length 8 cm of a circle of radius 5 cm. The tangents at P and Q intersect at a point T. Find the length TP. Before taking down this question, one thing that you should notice that I can directly start with the question and use the respective formula. But I want to take this question on a different path which involve different type of concept and the fundamental. This question is very important and this will clear many of your fundamental. I will take some extra time, but believe me, it will be worth. It will clear all your fundamental and you will be easily able to solve the future questions related to the same concept. So just be with me and build your basic fundamental. Let's proceed. Firstly, let's observe the question and the given figure. In the given figure, we are having a circle with center as O. The radius is given as 5 cm, which is OP. We are also having an external point T through which we are having two tangents, the tangent TP and tangent TQ. These two tangents are originating from an external point T, so these two tangents will be equal to each other. The theorem 10.2 we have applied. So TP and TQ will be equal to each other. And these two tangents are forming the triangle TPQ. This triangle, the two tangents or the two sides of this triangle are equal. It means this is an isosceles triangle. Further, OP is the radius and TP is the tangent. It means this angle will be 90-degree angle. The theorem 10.1. Just what I am seeing, I am observing the figure and I am trying to link it with the concept we have learned in the theory part. So this angle will be a 90-degree angle. Further, we are also given the chord PQ for this circle and the length of PQ is given as 8 cm. And we have to find the length of TP. That is, we have to find the length of the tangent TP. So this is the question. Firstly, let's join T with O. We got the line segment TO, which is intersecting the chord PQ at the point R. Here the line segment TO, which is joining the external point T with the center O, is bisecting the angle T. That is, these two angles will be equal to each other. This concept we have discussed in the theorem 10.1 proof. If you want to go into the detail why these two angles are equal, just check it out, our proof of the theorem 10.1. But still, I will again repeat some of the part as it will be important in solving this question and the future question. Here TO is the line segment which is joining the point T and O. T is the external point and O is the radius of the circle. This line will form two triangles and these two triangles will be congruent to each other. You can prove the same. So the corresponding angles and the corresponding sides will be equal. So these two angles are the corresponding angles which will be equal to each other. Note that these two triangles are congruent to each other. Congruent means exactly copy paste of each other. This concept you can apply in other questions too. Similarly, these two triangles will also be congruent to each other and these two triangles will also be congruent to each other. If you want to know how these are congruent, comment in the comment section. I will explain it separately. No worries. This is the additional information not required for this question, but these are the basic fundamentals that you should know. The question framer may try to trick you in the exam. If your basic fundamentals are strong, you can easily solve the question. So let's move further. Here TR or TO is the angle bisector of angle T and this is an isosceles triangle. And we know the property of an isosceles triangle with the angle bisector, that is TR will be the perpendicular bisector to the side PQ. TR, this line segment, is perpendicular bisector of PQ. Perpendicular bisector means these angles will be 90-degree and PR and RQ will be equal to each other. That is a property of an isosceles triangle that you can prove simply by taking the two triangles as congruent to each other. By SCS rule, you can easily prove that. I am not going into the detail of the same. Just note that TR or TO will be perpendicular to PQ. These angles will be 90-degree angle and these two line segments will be equal to each other. Got it? So we got PR is equal to RQ. PQ is given as 8 cm. So PR will be 4 cm and RQ will also be equal to 4 cm. So are you observing various right angle triangles inside this figure? This triangle is a right angle triangle with angle R as 90-degree angle. This triangle is also a right angle triangle at angle R. And this triangle is also a right angle triangle at angle P. So we can easily apply the Pythagoras and solve the question. So let's see. Let's take this triangle PRO. Here 5 cm is the hypotenuse. Let's apply the Pythagoras. On solving, we got OR as 3 cm. This line segment OR we got as 3 cm. After this step, we are having two ways to solve this question. And you should know both the approaches. One approach may be useful in some question, other approach may be useful in other type of question. You should know every approach so that you can solve all the question in the mid of the examination. So just pay attention for both type of alternative ways. In the first way, we will use the concept of similarities. Let's see. Here angle P is a 90-degree angle, and angle P is composed of OPR and RPT. So we can say OPR plus RPT will be equal to 90 degree. The addition is 90. Next step, if you observe this triangle, here angle R is a 90-degree angle, and if we apply the sum property of a triangle, we can say angle T plus angle P plus angle R is equal to 180 degree, and we know angle R as 90. So can we say angle T plus angle P is equal to 90 degree? That is, angle PTR plus RPT will be equal to 90 degree. Here let's compare both the equation. Both are equal to 90 degree, so we can equate both the equation. These two terms will cancel out. We got angle PTR is equal to angle OPR. These two angles are equal to each other. Further, if we compare these two triangles, here in these two triangles, these two angles are equal and these two angles are also equal, as both are 90-degree angle. So we can say both the triangles are similar to each other by angle criteria. Two angles of the triangle are equal. These two angles we have just proved as equal, and these two angles are 90 degree, so these two angles are also equal. Let's take both the triangle out of the figure for easy identification. In the similarities, the corresponding angles or the corresponding vertices of the triangle should match with each other. So we have rotated the right hand side triangle so that the corresponding angles can easily match with each other, and we can compare the corresponding sides easily, just for better visualization. If you are struggling with matching the similarities, the similar vertices or the similar angles, check out our complete series on the similarities of the triangle for class 10 student. So let's proceed. And we know once the two triangles are similar, the ratio of the corresponding sides are equal. Note that in the congruency, the corresponding sides are equal. In the similarity, the ratio of the corresponding sides are equal. So we can say TP upon PO is equal to RP upon RO. We know PO as 5, RP as 4 and RO as 3. On solving, we got TP as 20 upon 3 centimeter. That is the answer we are looking for. Got it? So this is one of the way we have used the concept of similarities. We have proved both of this triangle as similar, and we have used the concept that is the ratio of the corresponding sides of the similar triangles are equal. The second way is using the Pythagoras theorem, which is slightly easy as compared to these similarities, but you should know both the approaches. To make it simple, let's assume TP as x and TR as y, just for the simplicity. Here if we apply the Pythagoras in the triangle PRT, here x will be the hypotenuse. We got x square is equal to y square plus 4 square, which will be x square is equal to y square plus 16. Further, we can also apply the Pythagoras in the triangle OPT. Here the hypotenuse will be this complete length, which will be y plus 3. The complete length is y plus 3, which is the hypotenuse. So we got y plus 3 whole square is equal to x square plus 5 square. The basic Pythagoras we have applied. Now we got two equations. Let's solve both the equation. Here we got y is equal to 16 by 3. But in the question we have to find TP, which is x. So let's put y equal to 16 upon 3 in the equation. On solving, we got x as 20 by 3 centimeter. The same answer we have got through the previous approach, that is through the similarities. So the answer is 20 upon 3 centimeter. So this question is very important. Just note down some of the basic fundamental that can be used in solving other questions too. Here we are having a point T, which is the external point, and we are having two tangents. These two tangents will be equal to each other. And if we join T with O, that is external point with the center of the circle, we got the angle bisector of the angle T. So TO is the angle bisector, and this angle bisector is also perpendicular to the chord PQ. Note that not any chord, only the chord which is formed by joining the point of contact, that is P and Q. These are the point of contact of the tangent. So only chord which is formed by joining the point of contact is perpendicular to the angle bisector TO. This is very important. This will give the four angles as 90 degree, or these two lines are perpendicular to each other. And this angle is also 90 degree. The theorem 10.1, the angle between radius and tangent is 90 degree. So we are having this triangle as a right angle triangle. We can apply the Pythagoras in this. This triangle is also a right angle triangle. We can apply the Pythagoras in this triangle too. And this triangle is also a right angle triangle. We can apply the Pythagoras in this triangle too. But this triangle is not a right angle triangle. This is an isosceles triangle which two sides are equal to each other. Why? Because these two sides are tangent, and from an external point to a circle the tangents are equal to each other. Further, we can also take this triangle and this triangle, both will be congruent to each other. These two triangles will also be congruent to each other, and these two triangles will also be congruent to each other. Congruent means all the corresponding angles will be equal and the corresponding sides will be equal. So these all concepts you should know to solve the questions related to the circle. So that's it for example number 3. So students, we have done with this lecture. If you have enjoyed, like and subscribe to our YouTube channel, and also share this video with your friends and the class 10 student. We also have a similar kind of video, all the chapters for class 10 student. Check the playlist section of our YouTube channel. And best of luck for the exam you are preparing for, and have a great day. Bye for now.